attendees who come every time. It's very nice to see. Especially this year, because we actually have something to announce. You don't always. Sometimes we kind of have to creep up things to have a press conference about, but this year not so much. So good to see the familiar faces. But in case you're not familiar, and in case or in case you have a poor memory, I'll just remind you of who we are and who I am. Kryton is a family-run business based in Vancouver, BC. We've been around since 1973, and we specialize in concrete waterproofing for the most part. We had a history of making a wide variety of products. Our focus these days is on specialty items that we call smart concrete products. And we're here today, we're going to talk about our brand new sensor line of products. And with me today, we have Tobias, all the way here from Denmark. Tobias is the co-inventor of the technology we're going to see today, and of course a partner in the business in Denmark. And next to Tobias is Chris. Chris has been with Kryton for several years. He was our product manager for many years, and now he's taking on the role of representing the sensors throughout North America. So if you want to buy sensors, you'll be talking to Chris. But just again, a little about Kryton. We've been around for a very long time. We have distributors all around the world, and these are our offices. We have people in offices in about 10 different places around the world. And especially we have people spread around North America. So we've got an east and west rep for Canada, and then we've got 5 representatives around the U.S. To service customers. And then we have people in Europe, the Middle East, a couple people in the Middle East, India, there's 4 people in China, and we've got a guy in Singapore. We have, and it's founded by my father. That's my father in the middle, and our CEO is my sister, and I am the VP, and glad to be here talking to you guys today. So, in case you didn't know about us or never heard of us before, we are a pioneer of crystalline waterproofing for concrete, and we are the inventor of the original crystalline waterproofing admixture. And so this has gone on to revolutionize the way that people waterproof concrete structures that need waterproofing, especially basements. Our bread and butter projects are the underground parking of high-rise construction that needs to be waterproof. It generally is faced with hydrostatic pressure. And so, and they normally do that with a membrane system, some sort of expensive membrane wrap. We replace that. We replace not just the membrane, but of course the labor and the labor and materials to install it. And that has many great advantages. Having the waterproofing rate mixed into the concrete means there's no workmanship flaws, and there's no potential for the waterproofing to be punctured, for example. And of course, timing, the speed. There's no time required for installation, surface preparation. So it's a faster, better way to build. Now, about 2 years ago, I was here and I announced that we had purchased a company out of Calgary, Alberta. And they invented an admixture, another specialized admixture for hardening concrete. So again, instead of applying a surface, a dry shape material to the surface and troweling it in when the concrete was fresh, hard sand comes mixed right into the concrete, kind of like our Kim product comes mixed into the concrete. Hard sand comes mixed into the concrete. There's no labor required. There's no concerns about workmanship issues, about mist spots, about consistency, and of course the time, again, is the time required to apply it is eliminated. So today we're here to talk about Maturix. So Maturix is a real-time temperature monitoring solution for concrete, new construction. you need to monitor the temperature in many cases of the concrete, and temperature will tell you a great many things. I'm kind of getting ahead of myself, but the Maturix was invented by Tobias and his partners in Denmark about 2 or 3 years ago, maybe a little further back, but it really sort of developed into this finished product about 2 years ago, and they've had great success in Europe, just bringing this to the market, and people are eating it up. And then we found them, and we thought, gee, we should. This is a better mousetrap. We have, and I'll talk a little about why it's better than the other options. Probably the biggest advantage of it is its reusability. There are other sensors on the market. You might have heard of Geotac and some of these other guys that they have sensors that become embedded into the concrete. You attach them to the rebar, for example, and then you cast the concrete around them. And then what you do is you bring your phone nearby, and you can get the data from the sensor. And they call this wireless, and they call this remote, but you still need to come to the site with your phone and connect. It connects to your Bluetooth. The Maturix sensors are different. Maturix sensor sits outside of the concrete, and it connects to a temperature probe. These sacrificial temperature probes are cast into the concrete, and later they're just simply cut off. And they're very cheap, and they're very available. It's a very industry standard thermocouple. But the smart part of it is in the sensor that sits outside, and it connects wirelessly to the internet via the Sigfox network. Now, probably you've never heard of Sigfox, but Sigfox is a network, a low power, long range network that connects to all kinds of connected devices. So you've heard of the Internet of Things, where ordinary objects have some connectivity to the internet. They're connecting generally through a network like Sigfox. Now, Sigfox has become the world's largest, what they call zero-G network, the Internet of Things network. So it's all kinds of objects that connect, and the nice thing is that it works like a cell phone, where you don't need to have a local connection or a local wire connection or some sort of Ethernet connection. It connects wirelessly through the air to towers that exist in all major metropolitan areas across North America and really around the world. And the low power, it's a very little data that needs to be transmitted, so it means that the batteries will last a very long time, years in fact, depending on how many transmissions it makes. So you can see that it connects to these towers and then to the internet and then to your, or there are places where reception is poor and a tower is not immediately available. And so there is a hub that you can see on the bottom there that you can bring to a job site, for example, and it'll cover an entire job site. I think the range is about a mile or so. So it's more than enough to cover even the largest job site. And then you get temperature readings on your computer, on your tablet, or on your phone, wherever you are. And you can be anywhere that you have as long as you have a connection, you have a connection to the job site. So the nice thing about that is you never have to go back to the job site. Well, not I shouldn't say you never have to go back, but the idea is when you want to know what's going on with your concrete, you can see it right on your phone, see it on your tablet or your computer. So temperature is one thing, and it's an important thing. When you're pouring mass concrete, we need to know that the temperature doesn't rise above a certain level. That can cause problems in the concrete element. So the overall temperature is important, and also the difference between maybe the center and the top, the surface. The temperature differential is also important. And so you don't want that differential to become too large, or you can experience problems like cracking and so on. So the nice thing about this is wherever you are, you can set the software up so that you get an alert, like a text or an email. If the temperature, let's say you want to know when your temperature rises above 30 C, it can send you a text when it reaches that threshold. Or if the temperature differential becomes too large. We had a situation I saw in Denmark when we were there where it was cold, and they needed to keep the temperature warm. They had thermal blankets on top, and they were able to monitor the temperature. And without them knowing, the wind had blown one of the blankets off, and suddenly the surface temperature took a big dive. And he got an alert on his phone. He's able to see, hey, something's going on there. He phoned the site. They went out. They discovered that blanket had blown off, and they were able to catch that. So it's just a little interesting story on, being connected to your job site, even though you're lying on a beach somewhere nice. One of the other uses of temperature is, of course, temperature is closely related, or it's proportional to the curing time. So curing time is important in two phases. One, in the early stages, you want to know when your concrete will be set, when it gains enough strength so that perhaps you can strip the forms or load it or put it into service if it's a highway or a bridge. The other thing that you'd like to know is its later age strength. As it approaches a week, 2 weeks, 4 weeks, 28-day strength, you need to not only know when that happens, but you'll need to record that. That's important for quality control. It's important for being in compliance with specifications. And so what we can do with this is we can replace the need for crush tests. Now normally this is what you do. You cast cylinders along with the concrete when it's poured. You cast some cylinders, and then what you do is you take them to a lab and you crush them later to prove that the concrete has reached the strength. But this is a lot of guesswork. You have to guess when it's going to be appropriate to crush, and you don't always get it right. Also, the cylinders are not always representative of the actual in situ concrete, which can be much stronger than the cylinder. And the reason is because the mass concrete, being warmer than the cylinders, can cure faster and gain strength faster. And so cylinders are not, we've been doing it for a long time, but they're just not the most accurate or reliable way of determining strength. Come on in, don't worry about it. So with the software, and this is built in, the software is built in to the system, and the software is run on servers that Sensahive maintains, and the data is transmitted there. It's processed and sent to your phone. What we do, can't remember now, did we, didn't mention that when you want to relate temperature gain to strength, typically we would calibrate the mix. So you would take a given mix, a concrete mix from your supplier, and you would calibrate it in the laboratory using actual strengths and the actual measured temperatures to create a curve called the maturity curve. And the maturity curve is used then by the software to present to you what your strengths are in the field. So by measuring the actual temperature in the field and the given time, we can calculate the strength gain. And not only that, but you can predict, once you have a calibrated mix, you can see that, all right, I'm at this strength now, so I know that I'll hit 40 MPa or 6,000 psi or something by tomorrow or the next day, and you can schedule. So this allows you to schedule things accurately and more efficiently. And this helps you to build better, faster, right? Loading, stripping, saw cutting, all these activities require knowing when the concrete reaches a certain strength. And I think I mentioned, about recording this and being able to prove this compliance with specs is very important. So I think the takeaway from this is probably that these sensors have been around a long time, and people have used temperature probes to measure the temperature of their concrete, but never before we had a system where you have these reusable devices with the sacrificial probes that transmit wirelessly to the internet and then calculate through the use of calibrated mixes the present and future state of the concrete. It's a patented method, patented by Sensahai, and it's a tremendous innovation, especially as compared to what we have available prior to this. I think what I'll do is I'll get Tobias to just mention, I have a couple of case studies where this has been used that we thought were really interesting. And maybe we'll get Tobias to just talk about the Norway tunnel, and I think there's one or two that...
Yeah, so hi everyone, my name is Tobias. I am one of the co-inventors of Maturix and essentially co-founder of the company Sensahai from Denmark. So thanks again for the introduction and the presentation.
And if I got anything wrong, feel free to correct me.
No, I think I would love to elaborate a little bit on the whole, this is a new technology versus an old concept, and since this has been around for some time. And so essentially, the first sort of maturity models that are proven by ASTM standards or something are from 1949, I think. So it's really quite an old concept. So one of the relevant questions to ask ourselves is, if it's been around for so long, why don't we really use it, right? And the key answer to that is sort of that it was very complex to do. Back in the day, you would have to go and install some equipment and go to the site to get the data and maybe do the calculations by hand back in the 90s, or import it to a computer, where now using IoT technology, you can just basically have all the data transferred to the cloud and calculate it in real time. Okay, so what does that even mean for a project, right? So what we did was we have a lot of infrastructure customers around Scandinavia and in Norway. They're doing a lot of new highway construction. So we asked them, okay, they were doing it like an underpass tunnel. We said, okay, can you try to do everything like you normally do? And then we told one guy to say, okay, you get the sensors here, you embed it as prescribed, and then afterwards we'll look at, what would you have done differently if you were able to distribute this knowledge to the entire team. So what you actually see in the graph on the right are curing times for 11 casts. So this tunnel took 11 casts to make. So the red bar is the curing time that they actually cured before they stripped the foam, where the blue ones are the required time. So the blue bars are essentially the Maturix system measuring when they had sufficient strength to strip the formwork. So it took them 56 days to do the whole construction, and out of those 56 days, they could have saved 34. So it's more than 60% essentially in time saving, right? So realistically, of course, the 34 days are also 2 a.m. on a Saturday, right? So if the effective usage might be a bit lower, right? You might wait till Monday to strip it anyway. But the potential savings of doing scheduling and coordinating all these post processes that need to happen based on real-time strength measuring, instead of based on forecasting and cylinders that are field cured, is really potentially huge. So for them, it amounted to more than $200,000 savings on this one project, right? So we've done quite a few different projects, closer to 400 projects now globally. So one other interesting thing we always try to mention is when doing high-rise constructions, it's very common so this is a post-tension construction in Copenhagen. So they would cast the entire floor and then they would apply tension to the cables towards the elevator shafts to reduce the amount of load-bearing columns that were required inside the structure. We actually distributed 7 measuring points across the floor in order to determine when they were able to push tension in the rig. So it turned out that there was actually more than 2 days of difference between one side of the structure and another, as to when they reached the target that they wanted. And that was due to a diesel heater that was situated on the floor below that wasn't really distributing the heat efficiently, right? So they were actually able to correct that and save almost a day of time, so they could tension a day before than they expected, right? So we supply the system to precast factories as well, where you can embed low cost sacrificial sensors into the elements and essentially help time when you can strip them from the formwork and pull them out of the forms and so on. We run all production control on the largest single-site factory in Northern Europe. We were able to, by implementing this, we were able to reduce their waste by 35%, and it initially increased their capacity by more than 15%. That's without any machine investments or anything. The reason why that is simply that their production times fluctuate so much day by day, whether they are driving out material from the production zones or not. So is the gate open, and does cold air come in, is it windy, all of these factors. So they're used to applying standard curing times to their product, right? So this holocaust lanes, we usually do 10 hours and then we detention and cut it and drive away. So by monitoring every product that they actually produce, they know exactly how much time it takes. So they actually have screens, dashboards in each production zone, so showing them, okay, on our holocaust lane 5, it's currently at 67%. It'll be done at 4:15, and that makes it very easy for everyone in the factory to know when they should pull out the equipment or so. So they were able to to remove all their safety factors without having any strength-related defects. Yeah, I think that's sort of it. If you have any questions, feel free to ask. Thanks.
Okay. I think that's what we have. Oh, this is a quote from a fellow at Katera Construction. He says it all. The ease of use, you just literally just cast the wires into the concrete, and as soon as you plug in the sensor, it starts broadcasting to the tower. It couldn't be easier. The software setup is pretty simple. Not that you need to know, but Chris would be the guy who would set you up. If you were a contractor, you just need your email address, and we get you set up online, and you're hooked into the software, getting reports, printing reports. We need to print them, we're saving them. So, any questions? Yeah.
The data that are used